Hello all, welcome to Decode. In this video we shall see symmetry of binomial distribution. In the last video we had seen binomial distribution of a coin toss experiment. We had used the probability of head as 0.5 and probability of tail as 0.5. And this was the distribution we had got. And this distribution was made on the probability of number of heads in 6 coin tosses. At most we can get 6 heads in 6 coin tosses. At least we can get 0 heads in 6 coin tosses. This histogram is illustrating the probabilities for random variable values 0 to 6. The symmetry of this histogram, the binomial histogram, is due to symmetry of the probabilities used in our experiments. That is, probability of head is 0.5 and the probability of tail is 0.5. Otherwise, in other words, the probability of success and the probability of failure, we are assigning the equal probability. In that case, we will end up with a probability histogram symmetric. We shall now explore what will happen to symmetry of the histogram when the probability of success, in the previous case that is probability of head, is not equal to probability of failure, that is probability of tails. This scenario we will evaluate using the coin toss experiment. So we need to evaluate the scenario. If the probability of success, that is probability of getting head, is greater than the probability of failure, that is probability of getting tails. One way to materialize this is we will fix the probability of head as 0.5 and the probability of tail as 0.2. Or we can set, or we will further explore what is the shape of the probability histogram if the probability of success is less than probability of failure. That is, if I fix probability of head as 0.2 and probability of tail as 0.8. So these two scenarios we will see, and we will examine the shape of the histogram. Now to begin with, we will see if the probability of success is less than probability of the failure, what will be the shape of histogram. Here we have probability of head is 0.2 and probability of tail is 0.8. And number of trials in the experiment is 6. So n becomes 6. 6 times we are tossing a coin. And the random variable becomes number of coin tosses. Means the random variable x can take the value 0 to 6. So the probability of 0 heads in 6 coin tosses is given by. So x is equal to 0 and n is equal to 6. And the random variable x assumes the value 0 when we want to find out probability of 0 heads in 6 coin tosses. 6C0, number of ways we can get 0 heads in 6 coin tosses. 6C0 evaluates to be 1. And you can refer to the previous videos where you get extensive listing of number of heads in 6 coin tosses. I meant to say how many ways you can obtain 0 heads in 6 coin tosses, 1 heads in 6 coin tosses, 2 heads in 6 coin tosses, and 6 heads in 6 coin tosses. Everything illustratively I have illustrated in the previous video. The binomial distribution, in order to calculate the probability of obtaining 0 heads in 6 coin tosses, you need to multiply number of ways you can get 0 heads in 6 coin tosses, that is 1, into probability of success to the power number of ways you can get this, and probability of failure to the power number of ways you obtain the failure, that is 0.262. Likewise, we will calculate the probability of 1 head in 6 coin tosses, that is 0.393. We will calculate the probability of 2 heads in 6 coin tosses, that is 0.247. and the probability of 3 heads in 6 coin tosses is 0.081. Probability of 4 heads in 6 coin tosses, it is 0.015. The probability of 5 heads in 6 coin tosses is 0.001. And finally, we will reach the probability of 6 heads in 6 coin tosses is 0.000064. So you can see, as the random variable is assuming higher and higher values, the probability of heads in 6 coin tosses is diminishing. We will visually illustrate how the probability will diminish as the random variable value increase when you fix the probability of success lesser than the probability of failure. So this is the binomial distribution, or the histogram of the binomial distribution, where you can see the histogram is not symmetric because the probability of success and the probability of failure we have not fixed as equal. We have the probability of success as 0.2 and the probability of failure as 0.8. That means the probability of success is less than the probability of failure. During these circumstances, binomial distribution becomes positively skewed. That means it will have a longer tail in the positive end. So longer tail will be illustrated. The long positive tail is called as positively skewed. Any distribution we can call as a positively skewed if it is having a longer tail on the right hand side of its distribution. So the binomial distribution exhibiting here the longer positive tail, that means the positively skewed distribution. This positively skewed distribution becomes much apparent when number of trials in the experiments are greater than 10 or equal to 10. So in the previous experiment, number of heads in 6 coin tosses we had seen. Now we will examine if number of heads are greater than or equal to 10, what will happen, how the symmetry of the histogram gets varied. So this is one such outcome. Here you can see this is the binomial distribution when number of coin toss is 15 times you are tossing a coin, and the probability of success, that is probability of getting head, is 0.2. In this illustration, or in this histogram, you can clearly see the histogram is positively skewed. That means it is not symmetric. And one more thing, we have not still explored what is the binomial distribution shape or binomial distribution histogram shape when the probability of head is greater than probability of tail, or the probability of success is greater than the probability of failure. We will examine what will happen when the probability of success is greater than the probability of failure. Now we are fixing to examine this condition, that is probability of head as 0.8 and the probability of tail as 0.2. So this is the table which I am directly giving here. You can verify the probability of getting 0 heads to 6 heads when you fix the probability of success as 0.8, that is greater than the probability of failure, that is 0.2. You can verify it, the calculations are correct or not during when you work out. So one thing how you can validate whether your calculations are correct or not. The final column, the probability column, all the values needs to be adding to total to 1. The final column needs to be total to 1, then you can say the calculations are correct. If it is less than 0.9 or if it is greater than 1, then the calculations are not happened correctly. So this table is presenting the probability or the binomial distribution of a random variable x, where the x is the probability of getting 0 to 6 heads when the probability of success is 0.8 and the probability of failure is 0.2. Now we will see the histogram related to the distribution, or histogram related to the random variable we had in the previous slide. Here in this histogram you can visually see this histogram is not symmetric in the sense it is not foldable, equally foldable. So this kind of histogram is called as a negatively skewed histogram or the negatively skewed distribution. Normally, we obtain the negatively skewed distribution with the help of binomial distribution when the probability of success is greater than the probability of failure. Similar to the previous explanation, the longer tail means negatively skewed, right? If it is symmetric, it is not positively or negatively skewed. If any histogram is having longer tail in the negative direction, that means that histogram is the negatively skewed histogram. Again, this illustration becomes much apparent when the number of trials in the coin toss experiments are greater than 10 or equal to 10. Here is this histogram we have produced for a coin toss experiment for tossing a coin 15 times and fixing the probability of success as 0.8 and the probability of failure as 0.2. And you can see the probability of success, we are calling it as probability of head, and the probability of tail as 0.2. Here it becomes apparent that this histogram is negatively skewed and it is not symmetric. What we can conclude by this is, if the probability of success and the probability of failure are equal, then the histogram becomes symmetric. If the probability of success is lesser compared to the probability of failure, then the histogram becomes positively skewed. If the probability of success is greater than the probability of failure, then the histogram becomes negatively skewed. So this is about the shape of the binomial distribution. We have seen how to calculate the probability for the binomial random variable, and we had seen the distribution when the probability is different in the different circumstances. We have covered and binomial distribution, and now the binomial is decoded. You can download the materials which I have used for creating this video by following the description links. And if you want me to create any other further videos on any of your recommended topics, please drop your comments in the comment section. And in the upcoming videos with respect to binomial distribution, I will discuss normal approximation to the binomial distribution and the Poisson approximation to the binomial distribution. Thank you all. See you then. Bye.